for inviting me. Yeah, I'm just going to do a little bit of an overview of some of the work that I've been doing and kind of preview some of the stuff that I'm thinking about these next few days, or what I'm thinking about next, if I can figure out how to coordinate all this stuff. Oh shit, okay, the colors are wrong. So I've been working with computer vision and AI for more than a decade now, and when I started working with this material, it was hard to access these tools. So I was bothering people in computer science labs at different startups and that sort of thing, which kind of had mixed results. Finally, I was able to hire for my studio a full-time software developer, and we started building our own software that allowed me to kind of look at what was going on in academic research. I could kind of pull papers, look at the algorithms that were being developed, and put this into this software pipeline that we developed, and then that we were able to generate images using, right? So we're basically trying to build a tool that allowed us to see through the eyes of different computer vision algorithms and AI algorithms. So why was I interested in this question? Like, how do machines see? Why care about that? Well, I had noticed that something very transformative was going to happen in visual culture with the rise of things like computer vision and AI. And I also know that vision is complicated, right? Seeing is not just a technical process, but it's also a relational process. It's a historical process, a cultural and political process. And computer vision and AI are often described by the people who develop these tools in just purely technical terms. And when you hear vision or perception described in purely technical terms, it doesn't mean that those forms of synthetic vision are devoid of histories and politics. It just means that they're being ignored by the people developing them. So if that's the case, then what sorts of histories, what sorts of cultural assumptions, what sorts of politics are built into these kinds of technical systems? And I can think about the work that I've done, over the past decade or so as a process of trying to excavate those forms, excavate those assumptions that are built into so many AI systems. So one of the first things I started looking at was clouds. If we think about the history of clouds in art, this is partly a history of abstraction. You can look at someone like Turner, Stiglitz, and more recently someone like Gerhard Richter, someone like James Benning. So this was just making work, looking at clouds as a kind of abstraction, and then seeing what sorts of abstractions different computer visions or algorithms were making out of those initial abstractions, right? So we're seeing layers of abstraction here. But you can think about computer vision, and I certainly do, in relation to other forms of imaging and power from the past. I think about it particularly in relationship to the history of machine-assisted image making and colonialism. Things that you see in the history of Western landscape photography, for example, from people from the 19th century, like Muybridge, O'Sullivan, Watkins. So what is this relationship between technical forms of image making and power and colonialism? But I started thinking about other forms as well. What kind of forms are built into technical systems? What is the concept, for example, of a face that might be embedded in a computer vision system? And this was a project where I kind of went back to the first person to build a facial recognition system. It's a guy named Woody Bledsoe, who in the early 1960s got a secret contract from the CIA to invent facial recognition. And with the help of Professor Stephanie Dick, who had written her dissertation on Bledsoe, was able to get a hold of all his archives and notes on this project, go through them, and try to figure out what his concept of a face was. And he developed something called the standard face to do facial recognition. And this was a series of assumptions about what a face looked like that then you could make a mathematical abstraction of and use to try to individually identify people by looking at the deviations of a particular person's face from this standard face that he had made. And so I was able to go back and model that and realize that as a real thing, as a kind of a sculpture, this taking his mathematical representation and turning it into a physical object. And I started thinking about this as a kind of 20th or 21st century version of something like Greek sculpture, pulling out these idealized forms that might be part of the common sense of what is going on in a technical system like this. And so here in the earliest work on facial recognition, you start to see a kind of a story forming, not just a story about the development of technology, but a story about what kind of gets normalized, a story about the standardization of human figures, for example. And so I've gone through much of the history of facial recognition technologies and tried to do this same process, kind of make drawings or images that are based on the mathematical models of heads and faces that are built into historical computer vision algorithms. You can get more advanced than that. We started developing tools that tried to allow us to see into more contemporary algorithms. So I started doing projects, for example, like training a face recognition algorithm on figures from the past, and then trying to induce that algorithm to show me an image of what the ideal form would be of different historical figures. And we can talk later about why these look blurry, but basically what you're seeing is a statistical distribution of where different facial features would be. So you get this kind of blurriness. And we're doing that with objects as well, trying to find these idealized forms that are built into different systems. I spent a lot of work excavating training data, looking at training images. These are, of course, the large databases of images that are used to teach computer vision systems how to see, quote unquote, different kinds of objects. And when you start looking at this training data, not only the specifics of contemporary training data, but the history of them, you start to find all sorts of weird things. This is a very early training set, or details from it, from the early 1990s when the Defense Advanced Research Projects Agency funded something called FERRET. What was going on at the time was basically the military wanted facial recognition to exist. The CIA version of it from the 60s didn't really work. It wasn't really able to be implemented, but by the 1990s they thought, okay, well, we can do this. Problem was, in the 1990s, there's no Facebook, there's no Instagram. Where are you going to get a bunch of pictures of people's faces in order to do this research and to be able to test the efficacy of one algorithm against another? So they did two things. One, they went to military bases and photographed people that worked at the military bases. And this became this initial training set for face recognition called FERRET. But they had another solution to this problem of where to get faces as well. Who has a giant database of people's pictures? The police. Right? So when you look at the second really early facial database used for facial recognition, the second really foundational one comes from the faces of prisoners. And so these are very kind of, there's kind of a metaphor here that's also not a metaphor. You know, face recognition is literally made out of the faces of prisoners. And that is the paradigm. Now, spend a lot of time looking at other kinds of data sets and thinking about what the semiotics is, I guess, for lack of a better word, that go into training sets for object recognition. And this is an image from a data set called ImageNet, which is kind of really the foundational data set for contemporary machine learning and object recognition. And I've done a lot of projects looking at the relationship between an image and a label in terms of how these data sets are created. So what does it mean to label an image? So there's a politics to this. There's a politics that gets reproduced and reinvigorated when they're imported into automated systems. There's a kind of dynamic here. There's almost a theory of aesthetics or a kind of theory of semiotics that's built into computer vision systems. And I call it machine realism. And what goes on here is that there's an implicit assumption that has kind of several components to it. First of all, the assumption is that concepts, whether that's a concept like apple, or gender, or emotions, or a loser, it assumes that those concepts exist in the first place, and it assumes that those concepts are fixed, universal, and have some kind of transcendental grounding. Machine realism kind of secondly assumes that concepts have a measure of internal consistency. That, for example, there's some kind of measurable signal that can be found in all instances of an apple. Now, thirdly, it assumes a fixed and universal correspondence between images and concepts. In other words, between appearances and essences. And what's more, it assumes uncomplicated, self-evident, and measurable ties between images, reference, and labels. Now, these assumptions, of course, are not very good. Anybody who's studied, images or thinks about images in the way that we're taught to think about them as artists would contest this, and nobody who's thought about images for the last 10,000 years or so has made these assumptions about what is going on with images. So not only is this an incorrect way of thinking about how images function, there's a kind of very reactionary political corollaries to this theory of vision. And we see that in the data sets, particularly when we're looking at labels of people. And so what they did for ImageNet, for example, is they took a version of a dictionary, then they took all the nouns. And the assumption was if you're a noun, then you're a thing in the world. If you're a thing in the world, then you're something that we can make an image of and put it into a data set. What they failed to realize is that not all nouns are created equally. Like, we have horribly racist nouns, cruel nouns, misogynistic nouns, nouns that make no sense, nouns that are abstract, et cetera, and yet this sort of stuff ends up in the data sets and reproduces then the politics of this kind of labeling when these data sets are built into models. And so this is the installation that's, this one's up at the Louisiana Museum right now, which is kind of a story about nouns in machine learning and kind of about the politics of nouns. Now, I think a lot about what is a contrast to this kind of idea of machine realism. What's a contrast to the ways in which a contrast to the kinds of assumptions that are built into machine learning systems and computer vision systems. And I think that, allegory is much more paradigmatic of how images function now and have functioned historically. When we're thinking about an image of an apple, we very rarely mean like an apple, like you're going to take a bite of it. We're thinking about knowledge or sin or whatever it is. There's a huge number of associations we have with it. But the idea of just having a picture of an apple for the sake of having a picture of an apple, that's an incredibly specific use case, which is really not generalizable at all when we look at the history of images. So I started thinking about, can I use these sorts of technical systems to kind of generate new kinds of allegories in a way? And the other thing that I started doing is I started building my own models. And I wanted to try to build models that assumed different relationships between images, concepts, and essences. So I started building models based on literature, poetry, philosophy, and trying to induce the models I was building to generate allegories. You can take something like Freud's interpretation of dreams. You have a taxonomy of images in the interpretation of dreams, things like windows, false teeth, swollen throats, but these are not references at all to like architecture, dentistry, or oral hygiene. So one of the taxonomies I built was called the monsters of capital. And this was a neural network that was trained to see and to only see monsters that have historically been allegories for different moments in a circle of circuit of capital. It's building training sets. And then you have a model that looks at the world and interprets that world as if it could only see monsters that have been allegories for different parts of a circuit of capital. And then I was using the very early GANs to try to generate images of these monsters based on the data sets I'd created. And I created a bunch of these different kinds of data sets. This is the monsters one. There was a data set I made called the humans. This is the picture of a man that it generated. One of the data sets was based on Dante. And so where's this going? I want to just briefly preview some of the stuff that I'm thinking about now. A lot of this work is done over the last few years. But where are we going now? Where is generative AI going? Well, I think aesthetics are getting really, really fucking weird. And the aesthetics of the internet in particular are really, really bonkers. And this is something that Jack Ricker, who's right here, wrote a really wonderful essay about, and he called this psyop realism, right? So what's happening is that there's a kind of convergence happening between research on the neurology of perception and machine learning and generative AI. So let's take a step back and let's remember that the point of AI-generated culture is not really to make shitty art, right? Me and Molly were joking last night that, like, why the fuck are you spending like $1 trillion to put illustrators out of business? What's that, like a $2 million industry or something like that, right? It's not worth it. So what the fuck is going on here? So the point of generative AI is not to make shitty art, is to somehow figure out how do you extract value from places that were not efficiently accessible to capital, right? So let's think about what the commercial form of this type of media might be. And I think that it will be media that's specifically generated for each of us to maximally manipulate us. Not only in advertising, but in insurance, finance, labor, and other places where there is money to be made through extraction. So what kinds of metaphors can we use to try to think about this emerging mode of media and culture, one that is optimized for the individual manipulation of people? And I think that this metaphor of psyops is a really good place to start thinking about what this mode of media might be doing. And if you want to put this on a kind of a crude timeline, you can think about a shift from like the post-war society of the spectacle through the kind of surveillance capitalism and looking forward to this emerging age of psyops capitalism. And so what I've been...
My name is Richard Doty, and my favorite color is gray.
So in my most recent work, I've been trying to explore these dynamics of manipulation. What kinds of techniques are being used? How does the field of psyops theorize how to weaponize your perception against you, right? And one of the projects I've done in this body of work is a film I made with this guy named Rick Doty, who did some really weird psyops work for the Air Force in the 1970s and 1980s, where he was basically he was making like fake documents about UFOs and passing them out into like the world of UFO researchers and that sort of thing, and using that as a way to kind of cover up secret military projects. And the shit that he was putting out into the world sort of became the plot of the X-Files, because it became a kind of popular culture, just really, really bizarre guy. But has really a lot to say about how you do these kind of manipulation operations.
If they think it was something that we have, hey, that's something that we're going to defeat the Russians with. And you say, no, it wasn't one of ours. It was a UFO. No, that was. Then there's other ways we can convince them it was a UFO. Maybe stage something.
So I'm very much still looking at AI and trying to understand the dynamics that are built into it, but my focus now is more on how machine learning can and will be used to weaponize perception, and looking for analogies that I can use to understand that. So I've been thinking a lot about the history of things like mind control, of stage magic, of UFOs, and the relationship between those histories and phenomena and this emerging world of generative AI. Because, as Jack points out, culture has gotten very, very weird, and it's about to get a whole lot weirder. Thank you, guys.